What are related rates? Related rates are a type of problem in which multiple variables change at varying rates with respect to another variable, usually time. Related rates problems can help figure out the instantaneous value of a quantity that may change. They are usually word problems and serve as a common application of implicit differentiation.
So how do you solve related rates problems? First, you write out the given information. Seriously, actually write it out. Then, you write out what you're looking for and draw a picture if that helps you. Then write out what formula or formulae relate the variables, differentiate them with respect to t, and solve the problem. That may sound complicated, but once we do a few examples, it won't.
Example number 1. The height of a right triangle increases by 2 units per minute. The length increases twice as quickly as the height. At the time when the height is 3 units and the length is 4 units, how quickly is the length of the hypotenuse changing?
Most of the time, related rates problems are either just geometry or a word problem type application of geometry.
Example number 2. A 20-foot long ladder is leaning against a wall. The bottom of the ladder is sliding away from the wall at a rate of 2.5 feet per second. See the diagram. A. How fast is the top of the ladder sliding down the wall when x equals 12 feet? Note that this rate is the absolute value of dy over dt. B. How fast is the angle theta changing when x equals 12 feet? C. How fast is the area of the triangle changing when x equals 12 feet? B. How fast is the angle theta changing when x equals 12 feet? C. How fast is the area of the triangle changing when x equals 12 feet? Example number 3. Air is being pumped into a spherical balloon at a rate of 7 cubic centimeters per second. What is the rate of change of the radius at the instant the volume equals 36 pi? Note, the volume of a sphere of radius r is 4 pi over 3 times radius cubed. Example number 4. A conical water tower has a height of 12 feet and a radius of 3 feet. Water is pumped into the tank at a rate of 4 cubic feet per minute. How fast is the water level rising when the water level is 6 feet? See the diagram. Example number 5. If z squared equals x squared plus y squared, dx over dt equals 2, and dy over dt equals 3, find dz over dt when x equals 5 and y equals 12. Assume that z is greater than or equal to 0. Example number 6. A particle is moving around the ellipse 4x squared plus 16y squared equals 64. At any time t, its x and y coordinates are given by x of t equals 4 cosine t and y of t equals 2 sine of t. At what rate is the particle's distance to the point 2, 0 changing at any time t? At what rate is the distance changing when t equals pi over 4?